Question number 18. A small ball of weight W, small weight of ball of W is attached to a string and moves in a vertical circle of radius R. What is the smallest kinetic energy of the ball at X? At X, okay. At X, how much velocity it should have for the ball to maintain the circular motion with radius R? Now, why do you think the ball will not perform a circular motion? Let us assume that the ball does not perform a circular motion. Now, when can it happen, or what happens to the geometry here? So, let us say it goes until here. Beyond this, if it does not perform a circular motion, then what can happen? It can once again come down like this, right? Okay, or maybe it can fall directly here. So when does this happen? It happens when the string is not tight over here. In other words, it becomes slack over here. It is not able to go there. It becomes slack over here. So as a result of it, it can immediately fall down like this over here and come over here, right? So this is what can happen. So now, in other words, it can become a projectile motion from this point onwards. It will not even come down like this. Okay, it will become a projectile motion like this over here, which means throughout the path, it should have this some amount of tension. Here the tension is lower. When it comes here, tension is higher. When it comes here, tension is average. Here tension is average. Okay, here tension becomes lower, and until it reaches this point, it should have some value of tension. Maybe the minimum value of tension it can have at this point would be T equal to 0. The moment it crosses here, moment it crosses over here, what will happen? The tension should be regained. Okay, so which means that the condition now is that at the topmost point, tension can become 0. Until that, tension should not become 0. Right? So we need to have a starting point. So the starting point is at the topmost point. Let me call this point as point Y over here. At this topmost point, tension can become 0. Let us use this one here. So therefore, now let us draw the free body diagram for this. Let me erase this. This will take some time for me. It is not an easy question to immediately infer. Okay, but we need to work out a lot here to understand this. Okay, so now, so it's not a 1 minute problem until unless you know how does it work. So this is the object at the topmost point. This is the object at the bottommost point. So tension acts over here. Then your weight acts over here. So you can write tension plus weight is equal to mv square by r. And when you say the least kinetic energy, the tension can be, the least value of tension can be 0. Because if this has to be minimized, then definitely this has to be 0. So W should be equal to mv square by r. Call this as equation number 1. Then if the particle comes here and it should have an energy to start from here and to go until here. Now let us say the velocity at this point is u, which means it will have a kinetic energy equal to half mv square. Now let us apply your conservation of energy. What does conservation of energy says? The energy at this point, at point x, is half mu square, and then this should now be equal to the energy at this point. What is the energy at this point? It should be half mv square, because you should have some velocity over here, plus the potential energy, because it has climbed all the way along, right? So this should be, if this is the radius r, until here it should be mgr, until here it should be another mgr. So it will be 2 mgr, right? 2 mgr over here. Okay, and now what is he asking? He is asking you the kinetic energy. So what I will do is, I will write this as half mu square is equal to half mv square plus 2 mgr. I'll rewrite the equation once again the same way. I'll rewrite it like this. And what is mg? Weight, right? Now half mv square, we know that mv square by r equal to w. I'll write mv square equal to w into r, right? I'll substitute it over here. I'll write w into r by 2 and 2 into, what is mg? W multiplied by r. So we have wr by 2 plus 2wr. How much will this be? Which will be 5wr divided by 2. What is he asking? What is the smallest kinetic energy? The smallest kinetic energy at the point x. At the point x is half mu square, which should be 5wr by 2. Now look at this, which is the right option? D is the right option. Okay.